Hi, are you struggling with those time-sucking osmolarity questions on the NAPLEX? Let's simplify it with a shortcut you'll wish you learned sooner. Here we have a question. Calculate the osmolarity in milliosmoles per liter of a solution containing 0.6 milliequivalents per milliliter of sodium acetate. Molecular weight is 82, round to the nearest whole number. Okay, here's what most people do. Let's say step 1. They use the milliequivalent formula. Step 2, they find the milligrams using the milliequivalent formula. Step 3, they convert from milligrams to grams. Step 4, they plug in grams into the osmolarity or milliosmoles per liter formula, and they solve. Lots of steps, many chances to make a mistake. What can you do instead? Here's a shortcut. When converting from milliequivalents to milliosmoles or vice versa, you can use this. We can use this. Milliequivalents over milliosmoles equals valence over particles. So we can just take sodium acetate because that's what it's talking about in this question. Sodium acetate, we find the valence. Valence is 1 for sodium acetate. The particles, because it dissociates into 2 ions, our particles are 2. Let's move that over here. Milliequivalents that we're talking about right here, 0.6 milliequivalents per milliliter. I think I would like to keep on that milliliter just to remind myself so I don't lose it later on in the question. So I'll put it right there, 0.6. Now I am going to use X for the milliosmoles and solve for X. So we will cross multiply and divide. 0.6 times 2 divided by 1. What do you get? We get 1.2 milliosmoles per milliliter. Is that what they were looking for in the question? No, they were looking for milliosmoles per liter. They're looking for osmolarity, which is a concentration. How do I get there? I just multiply 1.2 times 1,000 milliliters per liter. You get 1,200 milliosmoles per liter. How simple is that? If you want to know any more simple tricks, come join us next Thursday for a calculations review. Hope to see you there. Bye.